Good morning, afternoon, or evening. This video is going to cover our rational numbers guided notes. Now, you should have received a cardstock piece of paper. It's likely going to be on yellow paper that has some fraction, decimal, and percent conversions you definitely want to study and be familiar with. That'll help you with some of these problems that we're about to see, converting between fractions and decimals to fractions as well. So let's start off by talking about what a rational number is. A rational number is any number that can be written as a fraction in the form a over b, where a and b are integers and b is not equal to 0. We cannot divide by 0. Any terminating decimal, that's a decimal that ends at some point, is considered a rational number. In addition, any repeating decimal, a decimal that exhibits a repeating pattern and can be written with bar notation that we'll review here, will also be a rational number. So basically, the only thing that's not going to be rational is a decimal that goes on forever but doesn't have a repeating pattern to it. One of those examples is pi, as you'll see down below. The third example down is 3.14159. It keeps going. That would actually be equal to pi, and pi is not a rational number. We call it irrational because it's a decimal that goes on forever without a repeating pattern. There are some other types of irrational or non-rational numbers. Those will be a lot of the square roots that you'll talk about either later on this year or next school year. So let's look at some examples of rational numbers. So 0.7 is a rational number. It is a terminating decimal because it ends in the tenths place. So it ends at some point. It is a rational number. The next example is -1/4. This is a fraction, and by definition, any fraction will be a rational number. We already talked about the third example down. Let's go to the fourth example down, which is 5.17 repeating. This is rational as well because it is a repeating decimal and we are writing it using bar notation. So this would be 5.171717, etc. And that will be a rational number. Eventually you'll talk about how to write that as a fraction, or in this case a mixed number in simplest form. The number -25 is an integer, and it can be written as a fraction as -25/1, or -50/2, or -100/4. It is considered a rational number. And then our last example, 150.285, that's another example of a terminating decimal, so it will be a rational number. All right, down towards the bottom part of that page, let's talk a little bit about writing repeating decimals using bar notation. So when writing repeating decimals using bar notation, the bar is drawn only over the digit or digits that repeat. So we're going to complete this table by writing each decimal using bar notation. So 0.11111, etc. If we write it using bar notation, that would be 0.1 with a bar over the 1 since that 1 repeats. The next one is 0.71111, etc. Since only the 1 repeats, we will put 0.71, but put the bar over the 1 since the 1 is the digit that repeats. And then our last example, 0.717171, etc. Both 7 and 1 repeat, so we will list both of them like we did for the prior example, but we'll put the bar over both the 7 and the 1 since they both repeat. All right, the big part of this lesson is going to be to write a fraction as a decimal. So I gave you that list of fractions and decimals that I would recommend memorizing. That way you don't have to use long division. But if it is not a decimal that you're familiar with or a fraction that you're familiar with, then you are going to need to divide the top number, the numerator, by the bottom number, the denominator. If you are able to rewrite the fraction with a denominator of 10, 100, 1,000, I would recommend doing this. If you have the fraction decimal combination memorized, then you don't have to show that long division. But we are definitely going to see some examples here in this lesson where we may not have those fraction or decimal combinations memorized. In fact, there's several of the ones we'll see today that I don't know off the top of my head without doing long division or using a calculator. But we're continuing not using a calculator for portions of this, although we will mix in some fraction and decimal things with calculators as we approach the end of the unit. I do recommend estimating your answer before doing the long division so you at least have an idea of where it is. That can also help you if you struggle a little bit with your basic multiplication and division facts. Now on the back of that first page, we do have a bunch of different examples where I showed the long division. I am not going to go through all of those examples since you could read through them. I will point out that the first one, 1/40th, is not one that I have memorized, so you'll notice that I did the long division here. And we'll talk through that with a bunch of examples. With this next one, example 2, to the right of the one that we just talked about, you can write -1/25th with a denominator of 100, as I did down here. That does make life a little bit easier. If we can work smarter, not harder, we might as well do that. But of course, you can also use long division, which you could do for any of them, really. It just takes a lot more work. The next one, -5/6, again, if we don't have that one memorized, I think that's on your fraction and decimal paper to memorize. But if you don't have it memorized, then you might have to do that long division there, which is no big deal. That's one that I do have memorized with just a lot of years of experience with this. The next one, 13/24. This one's in that bottom right-hand corner, and this one really takes perseverance. There's going to be a couple of those that we're going to see that are not going to be easy to do without having to do a bunch of math. Now, are you going to have 10 of these on a quiz or a test? No. But knowing your basic number facts and having really good skills with numbers really helps with this kind of stuff. So let's get right into our examples and make sure you're copying down the work as we go through these. And number 1 actually is an eighth, 5/8 specifically. This is one that is on that fraction decimal combination for you to memorize, that paper that you have. So 5/8 is equal to 0.625. If you have it memorized, you don't have to do the long division. And trust me, we're going to see a lot of practice with long division. So I'm not going to read through and go through all of that work here. But know that if you have it memorized, you don't have to show that work. You can just jot it down. You will not be able to use that cardstock like cheat sheet, if you will, on the quiz or test, but during class you can use it. So I do recommend memorizing the eighths. It does technically say to determine if the decimal is a repeating or a terminating decimal. This one would be considered, and I'm going to type it up here, a terminating decimal. Oh my goodness, I can talk today. A terminating decimal because it does end at some point. Now this next one, number 2, is also one you should have memorized. -3/4. It's the same as 3/4 with a negative sign in front of it. That's -0.75. You should definitely know 1/4 and 3/4 as decimals. So I'm definitely not going to show the long division for this one. Now, number 3, this one is also on that cardstock cheat sheet that you have. The ninths are there, and you probably are going to notice a pattern with the ninths. 2 ninths, I should go back, sorry, to number 2. This one is also a terminating decimal. It reminded me since our next one is a repeating decimal, but 2 ninths is equal to 0.2 repeating. In fact, if you have something that's in the form of a ninth, like 1/9, 2 ninths, 3 ninths, 4 ninths, it is going to be that top number that repeats. So 2 ninths is going to be equal to 0.2 repeating. Go ahead and slide that out of the way. This is what we would consider a repeating decimal, of course. And if you need to show the long division, we're going to take the top number 2 divided by the bottom number 9. So let's go through this work. So we've got 2 divided by 9. You can see that I added a decimal point after the 2, and I started with 1 0, but you'll notice I had to keep adding more. 9 goes into 2 0 times. Bring your decimal point straight up. 9 goes into 20 2 times to get us 18. 20 minus 18 is 2. We bring down another 0. 9 goes into 20, again 2 times. We're going to start to see a repeating pattern here. 9 times 2 is 18. We get a remainder of 2, bring down a 0. We're going to keep getting a remainder of 2, bringing down a 0, and we're basically going to notice that 2 repeats. So we can write 2 ninths as 0.2 with a bar over the 2 as a repeating decimal. So this is what our long division will look like. And you can stop once you start to notice that repeating pattern, but go far enough that you definitely see that it's going to keep repeating to be the same thing and not more than one number that repeats. For number 4, this is one that's on your little cheat sheet that you have, -4/5, but you can also rewrite -4/5 with a denominator of 10. -4/5, if we multiply top and bottom by 2, is -8/10. So as a decimal, that will be -0.8. If you put -0.80, that's fine too. This one, unlike the last one, is a terminating decimal since it ends at some point. right, let's take a look at number 5 next, 23/50ths. Now this one has a really nice denominator for us. It has a denominator of 50, so we can write it with a denominator of 100. I multiplied top and bottom by 2 to get 46/100ths, which we can write as 0.46. And this one is a terminating decimal since it ends at some point. Now I did recommend sort of estimating each of these before you do them. For example, if we go back to our 2/9, we know that 4.5 out of 9 is 50%. So we know that this is going to be somewhere around half of 50%, which it's pretty close to that. Whereas if we go to 23/50ths, we know 25/50ths is half, or 0.5. So 23/50ths should be a little less than 0.5, which it does happen to be. Now if we look at 9/22, we know 11 out of 22 is 0.5. So this should be a little bit smaller than that. This is one, though, where we're going to have to do some long division. So let me go ahead and reveal our long division, and then we'll talk through this. This is not an easy one. We're going to see that this is a repeating decimal, which I'll type in a moment. We're going to take the numerator of 9 divided by the denominator of 22. Now, 22 does not go into 9. I added a decimal point and a 0 here. 22 into 90 is 4 times. 22 times 4 is 88. So 22 times 4 is 88. 90 minus 88 gives us a remainder of 2. Bring down a 0. Now, before I brought down this 0, I noticed that 22 does not go into 20. So I did bring up a 0 above the 0 here that I had brought down. And then I can bring down another 0 to get 200. Now, 22 does go into 200 9 times here. And that's going to get us 198. So once again, we get a remainder of 2. If we bring down a 0, that 22 does not go into the 20 at all. I'm going to go ahead and highlight a little bit of that. But we've got this 20 here. 22 does not go into 20, so that's why I put a 0 up here. And then I bring down another 0, and 22 into 200 is a 9. So what I'm starting to notice is I have 0.4, and then it's 0.909, and that's going to continue. So the way we write this as a decimal, we can't forget our negative sign in front, but the way we write this is going to be negative 0.409, and that bar is going to go over both the 0 and the 9, not the 4 though, since only the 0 and the 9 repeat. And again, we can consider this a repeating decimal. That one is not an easy problem. There's a few of those mixed in. All right, the next one is also not a super easy problem for us. We've got 17/24. So this is not one I know off the top of my head. We're going to have to take 17 divided by 24. So let me go ahead and reveal my long division here. Top number divided by the bottom number, just like this. You can think top dog in the house. We put that top number under here. And when we go to work through this, whoops, I didn't mean to move my 0, my fault on that. I've got 24 into 1 and 17 0 times. Add a decimal point, bring it up. Bring over another 0 here, or add a 0 after the decimal point. 24 into 170 was not something I knew off the top of my head, so you can see I started with 24 times 6, and then I did 24 times 7, and recognized the 24 is going to go into 170 7 times. That's going to get us 168. We get a remainder of 2. When I bring down a 0, what I notice here is that 24 does not go into this 20 at all. So I have to put this 0 right up here above the 0 that I brought down. Then I can bring down another 0. 24 into 200, I recognize that that was 8 times. So you can see I brought an 8 up here. 24 times 8 is 192. 200 minus 192 is 8. Bring down a 0. 24 goes into 80 3 times, since 24 times 3 is 72. When I bring my 72 down here, 80 minus 72 gets us a remainder of 8 again. So I'm going to notice that I'm going to keep getting a remainder of 8, bringing down a 0. So this 3 is going to repeat. So this is another repeating decimal that is not an easy one. We're going to write this one as 0.7083 with a bar just over the 3, since that is the only digit that repeats. So this is a repeating decimal for us, but it does not repeat until we get to that 3. All right, negative 1/33. You will probably talk about a little bit of a trick or a shortcut to figuring this one out as a decimal eventually. We're not quite there yet, but at some point you might. So I did do the long division for this one. So let me show you this. This long division is not quite as bad as the last one. So we take 1 divided by 33. By the way, we know this should be pretty small since 1/33 is a pretty small fraction. But if I take 1 divided by 33, 33 goes into 1 0 times, 33 goes into 10 0 times, and I brought my decimal point straight up. Now 33 into 100, that's not too bad since 33 times 3 is 99. 100 minus 99 is a remainder of 1, bring down a 0, and I know that 33 does not go into 10 at all, so you're going to notice that I brought a 0 up here. And then I brought down another 0, and 33 into 100 is 3 times. So what I notice is a repeating pattern here. This time both the 0 and the 3 repeat. So I can represent this as negative 0.03 with the bar over both the 0 and the 3 since both digits repeat. And again, this is going to be a repeating decimal for us. All right, our next problem, number 9. Don't forget to pause as needed. You're going to notice number 10 is done for you. We'll reference this in a moment. Number 9, though, we have 11/40. We're going to take 11 divided by 40 here. Move that box out of the way. My computer is being incredibly slow right now. So 11 divided by 40. 40 goes into 1 and 11 0 times. Bring our decimal point straight up. 40 into 110 is only twice. 3 times gets us to 120. So 40 times 2 is 80. 110 minus 80 is 30. Bring down a 0. 40 goes into 300 7 times to get us 280. This is where knowing your math facts really can help here. 300 minus 280 is 20. Bring down a 0. 40 goes into 200 exactly 5 times to give us a remainder of 0. Since we got a remainder of 0 here and our decimal ends at some point, this is considered a terminating decimal, and it's going to look like this. It's going to be 0.275, which makes sense. We know that 10 out of 40 is 1/4, which would be 0.25, so it should be just a touch more than that, which it is. Number 10 happens to be a terminating decimal. This one is going to be a mixed number the way we wrote it. 5 3/8. If you have 3/8 memorized, that is on that cheat sheet that you have. It's 0.375. If you don't, you might have to do that long division. We don't need to worry about the 5. All you need to do is tack that in front of the 0.375 to make the final answer 5.375. So let's finish with a mixed number before we get to our word problem. We've got 2 and 4/11. You will likely talk about a shortcut for this one at some point as well, but let's do 4 divided by 11. 11 goes into 4 0 times. 11 goes into 40 3 times to get us 33. 40 minus 33 is 7. Bring down a 0. 11 into 70 is 6 times, which gets us 66. 70 minus 66 is 4. Bring down a 0. 11 goes into 40 3 times. We're going to see a repeating pattern that alternates between a 3 and a 6 here if we continue. So we've got to put that 2 in front of the decimal point and then the 0.36 repeating afterwards. So we can represent this as 2.36 with a bar over both the 3 and the 6 since those digits both repeat. So 2.36 repeating. Now our last word problem question here says the table shows the times of runners completing a marathon. To qualify for the next marathon, a runner's time must be less than 3 1/4 hours. Which runners qualify? Well, first of all, we have to recognize that 3 1/4 is equal to 3.25. That's our qualifying time, 3.25 hours. So when I immediately look at Kevin's time, I'm going to look here right away. 3.2 is less than 3.25. So right away, I know that Kevin is going to qualify. So I'm going to highlight him in yellow. Since Kevin's time, the 3.2 is less than 3.25. Now, something I should be aware of is that 3 1/5 is equal to 3.2. That's Cho's time. Let me move this box out of the way. Lovely computer. 3 1/5 is equal to 3.2, which is actually the same as Kevin's time. So Cho is also going to qualify since that time is less than the 3 1/4 that they need. Let's go to OHAS, 3 and 8/30. So I did do some long division here. I took 8 divided by 30. Now I was able to stop once I recognized whether OHAS did or did not qualify. So we'll take a look at our work here in just a moment. Sorry, my computer's freezing up a little bit on us here. So for OHAS, I'm going to take 8 divided by 30. 30 goes into 8 0 times. 30 goes into 80 twice to get a 60. 80 minus 60 is 20, bring down a 0. And then 30 goes into 206 times. That would get us to 180. So right away, I'm noticing that this is going to be 3.26, which is more than the 3.25 hours that we're looking for. So unfortunately, OHAS is not going to qualify. We can just put like a little X right here to show that OHAS does not qualify. Let's go to our last person, Sydney, and I took 13 divided by 60 here to determine if Sydney would qualify. 13 divided by 60, 60 goes into 1 and 13 0 times. 60 goes into 130 2 times to get us 120. That gives us a remainder of 10. 130 minus 120 is 10. Bring down a 0. 60 goes into 100 one time to get us 60. And I don't have to go any further because I'm noticing that 3.21 is going to be less than that 3.25 that they need for the qualifying time. So that means that Sydney is also going to qualify. So I'll go ahead and highlight her. And I did list the 3 people who qualified. That would be Cho, Kevin, and Sydney. Once I get this out of the way here, Cho, Kevin, and Sydney are going to be my 3-time qualifiers. Now, you notice this lesson is not very easy. We will spend some time working with calculators for some of this towards the later parts of this unit, or we'll mix them into some of our lessons. What will really help things is if you can memorize the fraction, decimal, percent combinations on that cheat sheet I gave you. That way you don't have to do nearly as much long division, because as you can see, when you have to do long division, it takes quite a bit of time. So I appreciate you listening. Hopefully you have all this written down. If you missed anything, make sure you go back and copy it down, but you want to make sure you have the notes for this stuff as we move forward into the remainder of our unit. Thanks for listening.